Welcome to tecversity. This is Venkatesh Natraj. Hope you all are doing great. In this video, I'm going to talk about ping. In the year 1983 December, Mike Morse has created a command and that changed the face of networking. He brought ping command. Ping is packet internet gopher. The ping word is pretty familiar for everyone. We use in our day-to-day life. Either we ask someone to ping on specific app like ping me on WhatsApp, or asking someone to share the details like, hey, ping me the details. From where this word ping originated? Initially, the ping was used underwater, and from underwater world, it evolved to digital world. In this video, I'm going to explain all the details and what are the ping commands and how they change the face of troubleshooting and how it changed the networking. We'll discuss in this. With no delay, let's jump into ping. And before that, if you haven't subscribed to tecversity, please do subscribe and share this video with your friends and family. Let's ping into the details. So I'm going to talk about the ping. Ping, the full form of ping is Packet Internet Gopher, and it runs on ICMP protocol. So what exactly ping does is, when in networks, when we do a ping command, we are trying to see the connectivity of two machines. For example, I have a machine A and somewhere I have machine B. And if I want to see whether this machine is connectable or reachable or is it available, I will do a ping. Now what happens when I do a ping is, machine A, from the machine A, I will be sending 4 packets of data to machine B using an echo request. And once the B receives that, and it will respond back to it saying that, hey, I'm available, I have received your packet, and it will give a confirmation. So that means once we receive a confirmation from machine B, that means the ping is successful. What exactly it means is the machine is available. So this is the basic troubleshooting that we do in the daily networking. On an average, 1 million times, network administrators will do a ping in a daily. In a day, we see that ping is used widely to test whether the systems are available or not. Now, we'll try to understand how come this has become so popular. Because when we see in general, when we talk to someone, hey, ping me the details in WhatsApp. Ping as a reference asking them to respond back to us. This is because the ping command is intention to receive the information back. That means there is an acknowledgement as well as the confirmation of what we are sending and receiving. So it is a way of saying the connectivity is up and live. Like I mentioned in my intro, from the underworld it came to the digital world, right? So what it is like, how come the ping was used before 1983, how the ping was used, let's try to understand that. So when the people used to, this is in the late before 1980s or before the even ping command came into existence. This under the water, we have submarines which will travel under the water, and they used to send a sound ping using sonar. Sonar in the sense sound, navigation and reachable. So this sonar technology used to send a sound ping to see whether is there any object underwater which will stop them, or is there anything that is coming on their way. So to figure it out whether is there anything on their way, they used to send the ping command, because the sound travels faster in water than the air. So that's the reason, because of the density of the water, the sound travels pretty fast and it can come back. It is 4 times faster than compared to air. Sound faster travel here in water. So the submarines used to do using the sonar technology, they used to send the ping sound, and that sound will travel and it bounces back because it will observe. The sonar device has an ability to observe when it echoes back, because when there is an object, it will hit it and it will echo back to the origin. So depends on that, they will understand how far is the other object in the underwater, and they will plan according to their route map, they will plan it accordingly. So that's actually the ping originated from the underworld, underwater, and from there it came existence to computers. Now, like I mentioned, in computers we will not just only, when we use a ping, like I mentioned, we have a computer A, computer B. By default, when we do a ping command, it will send 32 bytes of data 4 times. That means when we say, hey, ping a specific IP address to B, now this IP will try to send 32 bits of packet, data packet. It will send it to a destination. From the source, it will send it to destination, and that will happen for 4 times. Now, once it will travel back and come back, that is called time to live. So how much time that packet is alive. So once this machine will receive that, for example, computer A sent a packet of 32 bytes to computer B. Now computer B will respond, it will through, this happens through ICMP protocol, Internet Control Messaging Protocol. Now once this receives, it will bounce back that means it will echo that packet saying that, hey, I received it. Now this entire time travel of this packet from A machine to B and from B to A, that is called time to live. If you see, when you do a ping command, you will see typically 4 times we receive the in the command. Once you execute it, it will 4 times we see that data has been sent, received, and time to live. That time to live is actually the packet that's sent from A to B, and from B again it reverses back. That means echoes back to A. So how much time, what is the speed, how much speed it is taking for travel to come back. So that is called time to live. Now I'll show on the machine how when we do the command, I'll explain how exactly this happens. And not just the ping command, there are other attributes of ping which will give additional information. For example, when we do a single ping, that means we send ping.google.com. Now the machine will try to send 4 packets to google.com server, and google.com will also respond back to us. Now in this entire process, we are sending only 4 packets, which is 32 bits of packet 4 times, and we are receiving it back. Now we can also modify this, not just 4, we can continuously ping how many times you want. For example, I am troubleshooting a server, I am rebooting it. So to see whether the server has been rebooted or not, I'll do a ping space IP address and ping -a, that's the attribute, and give the IP address. Now in case if the server is reachable, it will continuously pinging and receiving the data. The data packets will be transmitted and will be received. It will not stop at 4. And if the server is down, then it will say the request failure, request failure, request failure. It will keep trying, and once the server is up, again it will say, hey, I'm receiving it. So this is a command, and under the ping we have these commands, like we have multiple attributes which will enhance the functionality of ping. Not just only the 4 packets, we can send anonymous data, and we can also tweak the number of bytes of packet that it's sending. Like I said, by default it sends 32 bits, right? Sorry, 32 bytes. Now we can also send a bigger size of packet. It could be a whatever the size you want. You can redefine that the packet size. You can redefine the packet size and you can send it out. So I hope this information is useful. Let's get into the system and try to understand how exactly this works. And I'll also put these ping command, whatever the additional attributes, I will also put it in the description, so you can have a look at it, and in case if you have any questions, you can get back to me. So let's jump into the machine to understand how exactly this happens. I'll also show in practical. I have a host and a virtual machine, so I'll try to ping to that host, and I'll run a ping attribute hyphen, so that it will see how much time it is taking for the how many times it is taking to connect to that machine, and if that particular server is not up and running, how many times it's trying, and when it is up back again. Now we can see how exactly this works. So with no delay, let's get into it. So I'm going to show now how to run this ping command and what all the other attributes that enhance the ping command to do additional options. Like when we run a ping command, it will just only the sends the specific amount of data, like 32 bits of packets to the from the source machines to the destination, and it will see what is the time to live, what is the time taken for each of the packet to come back. We will discuss on that. Along with that, we'll also see what commands will enhance the ping. I mean, not just only doing a ping, and what are the other options that will leverage an additional things on ping command. So here now I'll go to run and type cmd. In the sense, it will pretty much open the command prompt, or I can go with cmd/admin, which will give me the command prompt with admin privileges. Now I have here, so here I'm doing a CLS, that means I'll have a clean screen. Now here if I type ping space any specific IP address or a specific company website, or any company, for example, I'll try to ping microsoft.com. Let's see what happens. Now it is pinging microsoft.com with 32 bits of data, and we have got reply, and the time taken is 200 milliseconds. So now if you see, there is a slight difference in each of the packet that we received. So it is the first one, when it went, it is 200 milliseconds. The second one was 201 millisecond. The third one is 239 milliseconds, and the fourth one is 216. So let's run once again and see what is the time it's taking. So pretty much it's between 200 to 250 or 267. So, and if we see the other information like the ping statistics, it says this is the IP address, this is the IPv6. In general, we see IPv4, IPv6. So this is using IPv6, and the number of packets sent 4, received packets 4, lost is 0% loss. That means whatever the packets we have sent, we received it. And approximate round trip times in milliseconds is minimum 200 milliseconds, the maximum is 267, and average, if we see the count on an average, it's around 270 milliseconds. Now since this is IPv6, we are seeing a slightly different data. Let's try to see try to ping a server which is running on my host. Since I am running this machine, on this machine I have a virtual machine running, and let's try to ping it. So before that, let me see what is the IP on that virtual machine. So I have my server here, and let me see what is the IP address I have here. So the IP address is 172.21.70.64. So I'll ping here, ping 21.70.64. So this is the IP address, and now let's see how much time it is taking to communicate and to return that. See, this seems to be pretty faster than the when it's trying to connecting to the outside world. Now I have pinged to the virtual machine on my host, and it's pinging to that virtual machine, and the number of bytes sent is 32, and time is equal to TTL is 128. Now when we see the statistics here, 4 packets sent, received 4 packets, lost is 0, and the round trip in milliseconds is average. That means the minimum time for a packet to go and come back is 128 milliseconds. That's the standard. We cannot see anything below that, because that is the minimum time for a packet to travel and come back. So if you see you could see 129 or 130 or 160 or whatever, but you will not see anything below 128. So that's the reason it says minimum is 0 milliseconds, maximum is 0 milliseconds, average is 0 milliseconds. That means the connectivity is appropriate here. And let me see in a different way. So now I have pinged with the IP address. Now let me ping it with the name that it has. Now the name is server TV server 2, TV in the sense tecversity. So now I ping TV server 2, and let's see what it says. Now since it has the name, I have given the name, so it is using the IPv6 as the option here, and it's again the same. If we observe, it sent 4 packets, received 4 packets, and absolutely zero loss. That means the average milliseconds it has taken is 128, and there is no additional. Whether you give your name or IP address, it worked in the same. The only difference is it tried connecting with IPv4 or IPv6, depends on the availability, because I have given the domain name here, the server name. So this is how we run the IP. Now let's see. Now when I am running the IP, whether it's for a Microsoft.com or Google.com or within my machine, it is sending 4 packets, receiving 4 packets. Let's see how can we do if I give ping -server name and -t. -t is for unlimited. That means it will keep sending the messages. It will not stop. For example, let me show for Microsoft.com firstly, and I'm just giving -t as an attribute here. Now if you see, it is keep pinging. Now it will not stop until I say cut it or stop it. Then I just need to press Ctrl+C on my machine and it will stop. Now what happens here is it is continuously pinging to Microsoft.com and receiving the packet, and how much time it is taking on an average, we can see it here. So this will not stop until I press Ctrl+C. Now I just pressed it, and you can see how many packets sent, 26, how many received, 26. Approximate time is minimum 200 milliseconds and the max is 270 on an average, including because we see 238, 201, 239, 231, 259. So the average is 210 milliseconds. And like I mentioned, I have given Ctrl+C, so you can see the Ctrl+C command has been showing up here. Now I'll try to ping internally on my machine. So I'll go here. I have given the IP address and -10, sorry, -t. This is for my machine which is running a server on my host internally. So it is also keep sending the data. You can see it. It's continuously pinging and it is sending 32 bits of data, and average time it is taking is 128 milliseconds. Like I mentioned, that's the minimum. We cannot change it. So now until I press Ctrl+C, it will not go off. Now let's do one thing. I will turn off this machine and I'll try to restart this server. So I'm restarting. Let's see now what will happen. Since this is continuously pinging to it, now it should have a stop because it should lost the packet. Now I see the request timed out because the data is lost, and again it started pinging. That means the server must be up and running. Let's see. So I'll open my Hyper-V console and see whether the server has been up and running. So from 17 seconds the server is up. So now I should be able to access on my remote desktop app. So yeah, server is up. So if you see, the data has the requested timeout, there's once it got failed because the data is continuously sending and receiving. So let's try to see once again. I'll just shut it down for a few minutes. Instead of restarting, I'll shut it down and let's see what happens. Now I see that it is still pinging. Now the ping has stopped because it's not able to send, and it is able to send but it's not able to receive it. That's the reason the request is timed out. Now until I turn on the system, this command, since I have given -t here, this command will keep executing it until I press Ctrl+C. It will not stop. Now I will go to my Hyper-V console. I will turn this PC. So I have turned on the PC and let's see how much time once it started running the operating system, it will start pinging. See, you can hear now the server is running and the ping is successful. Now if I press Ctrl+C, we can see the packets sent 94 and 85 packets received because there is a loss, and the loss is around 9%, and the average time is the same and the maximum is 1 millisecond. Now you can see since it is running on the local, there is no difference in the time, but the only thing is I have rebooted on once and we lost 1 packet of data, and when I shut it down we have lost some data, and that's around 9. So yeah, pretty much this is about a ping. Hopefully this information is clear. I'm providing more details here. Let's see, just a minute. So well, now let's try to understand what is TTL, because TTL is when we are sending a packet from our machine to the destination, and that packet, how much time that is alive. That means once we send the packet from our machine and we receive that packet back, the time it is generated, it started and turned it back, that is the actual time to live. So it's very important to understand the time to live, because depends on the TTL we will understand the connectivity is up, good or bad. Sometimes the ping command will say we are sending the packets and we are receiving, but the time is taking too long to receive the packet. That means there is a lag in the network, or there is a bandwidth issue that needs to be addressed. So for that purpose, the TTL is extremely important to understand what exactly happens in TTL. Let's see. So when a ping request is sent, the TTL value is set at the packet header. Now, and when the data packet is sending, at that moment itself, the on that packet header itself, the value has been set, and each time the packet passes through a router, the TTL value is decremented by 1. That means when it is moving out from our router, immediate router, the value will keep reducing. Now if the TTL reaches 0 before reaching the destination, the packet is discarded. So once we are receiving, and if we see the TTL value is 0, that means the packet is not useful, because it is considered as discarded, and the router drops the packet, typically sends ICMP like saying that its time exceeded. Like how we see the request time exceeded, we will see something like that. And this mechanism ensures packets do not circulate forever. There is a routing loop, so it will not keep sending the same packet, and we will not get fooled out of it. That's the reason this entire TTL technology has been included in this ping command, to help us to understand how much time it is taking for the data to transfer and to return back. Now this is extremely important. Like I mentioned, the bandwidth will be identified only if there is a congestion in the bandwidth, and if the network is slow, we will figure it out by this command, ping command, to know the packet, how much time it is taking. Hope this information is useful. If you have any questions, please feel free to drop a comment. I would be more happy to respond back. And please make sure you subscribe to tecversity, and if you have not subscribed yet, please make sure you subscribe to it, and ensure you share this video with your friends and family, and make sure you click on the bell icon for the next videos, get notification. Yeah, pretty much that's it for today. Have a good day. Bye.